Okay. In this example, we will find the stress due to a moment that is at an angle. So it's not just on Z or Y. Usually what we did, so we have a beam. What we did before is that we have a beam. Our system is in X and Y, so the moment is about the axis Z, right? So when we have a moment about the axis Z, we create, let's say with a little positive guy, we create compression on the top and tension on the bottom in this case. Okay, and now the question is, what do we create on the four sides? So we have the beam like this. And instead of having just a moment on Z, we have also a moment on Y, okay, in that direction. So we have a global moment in that direction, and we create tension and compression on the bottom and the top. So we will study that. Let me get that away. That's our little parentheses, and let's work on those this example. So I will split the moment on the two components. So we have the my. So we have the my equal 500 cosine 30 equal 433 Newton time meter. And we have the moment on Z, this one, mz, and I forgot to show the direction of the rotation. So mz, that is equal to 500 sine 30, the angle theta, that is 250 Newton time meter. Okay, the green moment is in that direction. So what we need to do is we need to look at both moments independently. So we will have, I will draw this surface 2 times, and we will look at only the effect of my. So what's happened is that those fibers are going up, tension, and those fibers are compressed. They are going into the bar. The bar is below there. So those one are in tension, and those one are in compression, and everything in between, right? This is my triangle, like this. So down and up. And we have, so this is my, so this one in tension, that will be the plus 43 times 0.1. Why 0.1? Because the side is 200 millimeters, so it's 0.2 meter. So the y equals 0.1, and the z also will be equal to 0.1 because it's a square. So the distance from the center to the side is 0.1 everywhere. So the fiber in tension will be submitted to a stress of 433 times 0.1. We need to divide by j. Let's do that at the end. And the compression minus the 433 times 0.1. So let's write for all our corner. Our corner, we have A, B, C, D, A, B, C, and D. So sigma A, sigma B, let me put some space, sigma B, sigma C, and sigma D. Sigma A is in compression, so minus 433 times 0.1. Sigma B is in tension, so plus 433 times 0.1. Sigma C is in compression, tension, so plus 43 times 0.1. And CD is in compression, so minus 433 times 0.1. So B and C in tensions, positive, positive. A and D are in compression, negative, negative. And we need to redo that for the other one. So we redo our section. Okay. And this time we will look at the effect of the moment mz. So mz is this way and turn this way. So those fibers are in compression and those fibers are in tension. And we have our 0, oops, 0. Ah, I keep banging on. I don't know, my toolbar doesn't go back very fast. Here we go. I promise I try to block it, all of that doesn't work. Okay, this one and this one. So this and the bar is like this. So the bottom, the C and D, those points on the bottom are going inside the rods are in compression. So we have compression that will be minus 250 times 0.1. And this one they are in tension, so that's a plus 250 times 0.1. Okay, and the points again, this is A, B, C, and D. So now we can add those stress. So point A is in tension, so plus, I really try to not to type on the plus 250 times 0.1, sigma B plus, oops, it's a plus 250 times 0.1, sigma C compression minus 250 times 0.1, and C minus compression 250 times 0.1. Oops. Okay. So we just forget something. The formula is sigma equal my divided by j. I will explain this minus after that. Even more for our formula there, because we have to think the formula is, so I don't make, minus mzy divided by j plus myz divided by j. I will explain those signs, but for now what we need to do is like we need to divide by j everything. So divide by j, divide by j, divide by j, and divide by j, and we can find j equal 112 of bh cubed. It's a square, so 112 of the side is 0.2 at the fourth, and this is, I got that value somewhere. Oh, I changed that. Okay, let me change that. 1.33 times 10 at the fourth meter fourth, at the minus fourth, right? At the minus fourth. Okay, so we got, let me replug my data correctly, 5 and 30. Okay, we got minus 137 and 260 Pascal. That is equal to minus 137 kilopascal. Second one, we got 512 something, 260 Pascal. That is equal to 512 kilopascal. This one will be the 137, 260 Pascal equal plus 137 kilopascal. And this one will be minus 512, 260 Pascal. That is 512 kilopascal. So overall, the point A is in compression, the point B is in tension, the point C is in tension, and the point D, okay, I'm missing a minus there, is in compression. And if we come back on that, that makes sense. So if we look, oops, pop up. Okay, so the easiest one to check is like B. B is tension, tension 2 times. B, tension, tension. Point D is compression, compression 2 times. So this is this one. And after that, A is a combination of tension and compression, and C is a combination of tension and compression. So those answers make sense. So now let me explain those minus. So the formula in the textbook or whatever is minus mzy divided by j plus myz divided by j. So what's happened is like we have the my positive and the z, and those fibers there are in tension. So when we use the my positive times the distance z that is positive, we get positive in tension. But when we use the mz and the y is there and the mz is going in that direction, Okay, so the positive mz creates compressions at the positive y. And remember, we want that compression are negative. So we need to inverse the sign for the mz times y. And not for this one. You see the moment and the z and the moment and the y, they are not in the same direction. So we need to inverse the direction of one of them. Okay. What you have to remember, those signs, I don't insist too much about the sign. What you have to remember is like, look at what's happening. If the fiber are in compression, that should be negative. If the fiber are in tension, that should be positive. That's the easiest way to remember. So here we go. And this is also why we have the negative sign on the formula just by himself, because the top, when the moment is positive, the top fibers are in compression negative. So that's why we need to include the minus. So hope that makes sense. Enjoy this problem. Bye-bye.